Okay, today is August 31st, 2020, and we are going to be finding the equations of lines, but before then, oops, I need an S there. There. Before we do that, we get some word problems. Okay, let's check this out. A function a of s given as a of s, or a at s, equals 0.328 s plus 46 can be used to estimate the average age of employees of a company in the years 1981 to 2009. Let A of S be the average age of employees and S be the number of years since or after 1981. Now, what that means, and we've talked about this before, I think, this is a very common way of showing the measurement of time. When you start counting or start measuring, you let that be your year 0. And then, for instance, yeah, they're letting 81 be 0. Okay, then 1982 will be S equals 1. I don't want that comma there. And 1983, so on. 1983 will be S equals 2. And then they point out to you that 1990 will be year 9. And that just makes it much, much easier to make a graph, because to a computer or to a graphing calculator, 1991, for instance, would be the year 1991, and that would be way out on the x-axis, located at 1991. So you can translate it back in to where we normally put graphs, which is pretty near the intersection of the y and the x-axis. Okay, so that's the reason for doing this. Also, that it's just easier to write smaller numbers than it is to write bigger numbers. So now let's see what we're supposed to do. They want to know what was the average age of employees in 2003 and 2009. Well, we have our formula here. But we have to translate the years 2003 and 2009 into what S equals for this formula. So we're going to do that, and we're going to do this in the following way. 2003 minus 1981 is going to equal, and you can bring up your calculator to get that if you want to, 2003 minus 1981 is 22 years. 2009 minus 1981 would be 6 more years than that, which is 28, I think. Yes. Is that right? Yes, it is. Okay, so now we know that the year 2003 is the year S equals 22, And the year 2009 is the year S equals 28. So now we're just going to calculate the answers to the questions using A of S. Now the reason I'm writing it so big, you'll see in a minute. Okay, this is 2003, year 22. So A of 22, what this is this is a computer code or math code, but a math code and a computer code are pretty much the same thing. This tells me to take a 22 and put it in for the S. And 2009, and that's how you actually use a function in real life. Probably somebody would have already programmed a computer and you can just shoot those years in. Now, one of the wonders of the TI calculator, one of the things I really like about it, is that I get to do the following. 0.328, parentheses, isn't that great? 22 plus 46. Enter. Now that should be 53, and as I recall from the instructions, we are rounding to the nearest whole number, which means, okay, remember that on this side of the decimal, that's the whole number, and the decimal part is the fraction number. So this 2 following the 3 will not cause the 3 to round up. So our answer is going to be 53 to that. So the average age of employees in this particular company was 53 back in 2003. Now we're going to see what it was back in 2009 by using the same kind of method. 0.328. Now, since 22 and 28 are positive numbers, I don't really have to use parentheses. I could have just said times up there for 22, but I am going to say that for 28. 28 plus 46. Okay, I don't have to worry about the calculator thinking, oh, 28 plus 46 is whatever that is, 54, 64, 74, whatever it is. Because it knows order of operations and you always do multiplication before you do addition, so it would just naturally, the calculator would just naturally go ahead and multiply these before it would add that. So we don't have to worry. Okay, now, same kind of situation here. Since this 1 will not cause the 5 to go up to a 6, we can just go ahead and drop off the decimal parts and say, okay, in 2009, the average age was 55. And those would be the answers to this question. The whole purpose of this question is to try to help you see how functions are really used in everyday life. They're used a lot. And they're usually turned into, they're used as parts of computer programs largely. Any more discussion on that before I go on? Okay, now this is interesting. Does anybody, any of the people out there, do any of you go diving? You know, with scuba and all that? I don't. No, I don't. But this problem is about that. It's about the pressure underneath the surface of the ocean. The function P of D equals 1 plus D over 33 gives the pressure P in atmospheres, which is how it's measured, at a depth D. So D means depth under the surface of the ocean, and depth is measured in feet. Now it says, note that P of 0, that would be on the surface, would be 1 atmosphere. And P of 33, if you put a 33 up here, that would be 1 plus 33 over 33. 33 over 33 is 1, so that would be 1 plus 1 is 2. And indeed, P of 33 would be 2. And so on. It wants you to find the pressure at 120 feet. And I went ahead and I included the answer box because this blue typing is something you should always read when you're doing work in MyMathLab. And that is, it tells you what kind of answer to give so that you'll get full credit. For instance, if you give a decimal answer when they want you to give a fraction answer, it's going to count you completely wrong. So you have to be careful to read these blue letters, which are usually underneath the answer box, these blue words. Okay, now here it's not a big deal, just says type an integer or a simplified fraction. Okay, now what I'm going to do is I'm going to find P of 120. And that means put 120 up here for D. And now I pull out my trusty calculator. I hit clear so I don't get confused with anything I might have already written. And here we go. 1 plus 120 divided by 33. Now, if I just hit enter, I'll get that ugly thing, and that is not the kind of answer they want. It's not an integer or a simplified fraction, but I can get a simplified fraction by doing the following. I can you see the math button there. I can press the math button, the math key, and this gives me this menu. And frac for fraction is right here at the top. So I'm going to hit, you see how 1 is highlighted? All I have to do to accept 1 is is hit enter. And now I'm going to hit enter again, and I discover that the answer that they're looking for is 51 over 11. So I'll write that out, 51 over 11. And you know by now that the answer boxes expand in MyMathLab. And that's all there is to it. But if you're interested in what that really means, because who goes around measuring like that? It means a little over 4.5, wouldn't you say? In fact, almost 4 2/3. Now, what that would mean in atmospheres, I don't know. To me, I don't know anything about diving. It would mean it's closer to 5 atmospheres than 4 atmospheres. Is that good or bad? I have no idea. No idea at all. But those are our word problems. You have one more that is just like this one. So, and like, like the first one.
Miss Barbara, don't forget to add another 3 under the 120.
Oh, 33, yes. What did I type? Did I type 33? I don't know. I bet it's not even going to be there. I did, thank goodness. I typed 33. I just forgot to write it. Thank you so much. There you go. You've got to be a math teacher, Myra. You've got to be a math teacher. Okay, let me save this before we go on to the equation of lines, because lines represent something important in real life. Nobody plays around with lines because they want to get good at math. They play around with lines because they're already good at math and they're trying to calculate something in engineering or in economics or in medicine. And so each point is very important. And if you want to find the points, you have to have the equation of the line. So now we're going to talk with simplified examples, how to find the equation of a line. It's really how to find a formula, because equations of lines are really formulas for finding points. Okay, so it says find the equation of the line having the given slope right here. They give you the slope, so it's called the given slope. And containing the given point, because they give you the point, 6, 1. You've got the slope 3 and the point 6, 1. Now, let me make a commercial break here, take a commercial break, and point out to you that so far you're very familiar with 2 formulas for lines. There's slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. And then standard form, which is ax plus by equals c, where a, b, and c are just numbers, and x and y are the traditional x and y. Okay, but there's a third formula that you use when you're trying to find the equation of a line, and that's called the point slope formula. So we're going to be using that today, the point slope formula. And what that does is that gives you the equation either in slope-intercept form, if you need it that way, or it gives you the equation in standard form, if you need it that way. Okay, well, I've got a point and I've got the slope. So we're going to do this. The point slope formula is y minus y sub 1 equals m times x minus x sub 1. And normally what we do is we just say y1 and x1. And guess what y1 and x1 are? Right here, x1, y1, the point you're given. And so when I write this, I'm going to have y minus y1 equals m times x minus x1, and that'll be y minus 1 equals 3 times x minus 6, and now all I have to do is work this out. Okay, I'll have y minus 1 equals 3 times x minus 6 times 3, or 3 times minus 6. That'll be minus 18. Then since it does say somewhere farther on here, in fact, for all of them, to give the answer in slope-intercept form, you know we have to solve for y. So I will add 1, there, crooked 1. And what that's going to give me, negative 1 plus 1 is 0. So y equals 3x. Now, negative 18 plus 1 is negative 17. And so the equation of the line that has slope 3 and goes through the point 61, the formula, the equation is this right here, y equals 3x minus 17. So the point slope formula helps us work that out. I'm going to get rid of this so people can see this. Oops. Okay. Okay, notice when I'm thinking about it, I can make the European one. When I'm not thinking about it, I just make the American one. I should just stick with the American one because I'm not really good at the other. But anyway, that was our first problem. Any discussion? Okay, here's another version of this, except it has more words. Find an equation of the line with slope 5 and containing the point negative 1, negative 3. And notice it says down here, simplify your answer, type your answer in slope-intercept form, use integers or fractions for any numbers in the expression. So what that means in simple English is no decimals. Okay. So here we go. Y minus y1 equals m times x minus x1. So negative 3 is y1, negative 1 is x1. So I'll have y minus negative 3 equals 5 times x minus negative 1. And now before I start distributing the 5, I'm going to take an extra step to acknowledge that negative negative is positive. Y plus 3 equals 5 times x plus 1. Okay. Now I'm going to finish up. I'll distribute the 5. So I'll have 5x plus 5 and over here y plus 3. But I have to solve for y. So let me subtract 3 and subtract 3. 3 minus 3 is 0. So I'll have y equals 5x. Over here I have 5 minus 3, which is 2. And so this is going to be the equation of the line that has slope 5 and goes through this point. And it goes through an infinity of other points, an infinite number of points. But that's one of them right there. -1, -3. And that's all you need to use the point slope formula. You need to know the slope. All you need is 1 point. Okay? Now I think what? Yes?
Oh no, I was just saying yes, ma'am.
Oh, okay. Okay, now it's going to get a little harder. They were nice to give us the slope. Now we have to find our own slope. All we're given is 2 points. Find an equation of the line containing the given pair of points. 3, 1 and 9, 5. And then the instructions for the answer say to simplify your answer. Type your answer in slope-intercept form. Use integers or fractions for any numbers in the expression. In other words, don't use decimals. Okay, well, I have to find the slope first. You always have to have the slope first. It's nice when they give it to you. So m equals y2 minus y1 over x2 minus x1. So I have to decide up here, and I'll just do it the way I usually do it. You can choose to do it differently, but once you make your decision, stick with it. So I will have 5 minus 1 over 9 minus 3, and that will be 4 over 6, and that reduces. 4 is 2 times 2, 6 is 2 times 3. The 2's cancel, and your answer is 2/3. But your calculator will do it for you. Let's do it. The answer I got was 4 over 6, 4/6. So 4 divided by 6. Now, if I push the math button, click on the math button, and choose to frac it, and frac it again, notice it automatically gives me every fraction in lowest terms. So if you find reducing fractions strains the noodles in your brain, never fear, your calculator can come to the rescue. Okay, anyway, I have the slope now. Now I can actually choose either point. All that matters is which one is easier. I can choose either point to be my x1, y1, but quite honestly, this looks easier than the other one because the numbers are smaller and I'm a little bit lazy. So let's choose x1, y1 to really be x1, y1. And here goes the point slope formula. Y minus y1 equals m times x minus x1. And so we'll have y minus, 1. Y minus 1 equals 2/3 times x minus 3. Okay, now for those of you who get nervous dealing with fractions, you don't have to, because it's amazing what your calculator will do with fractions. Just chew them right up. Okay, I am going to take this little number right here, and I'm going to distribute it to x and distribute it to minus 3. So I will have y minus 1 equals 2/3 times x minus 3 times 2/3. Now, in my opinion, it's just as easy and just as quick to turn your 3 into a 3/1. And notice that your 3's cancel. A 3 up there and a 3 down there cancel when you're multiplying. Not adding or subtracting, but multiplying. So now I know that that leaves me with 2/1, which is 2. I'm going to do it on the calculator in a minute, though. Okay. But if you don't feel comfortable with that, because in my generation, I'm old, there weren't any graphing calculators or any kind of calculators. There weren't any little hand calculators that you could use back when I was young. So we had to actually learn to do it right on paper the long way. Well, now there are calculators to save you from all that torture. And let's do what you would do with your TI 83 or 84. All you have to do is remember that the number carries the sign in front of it is, okay, here's the negative. You use this with a negative, not the minus sign. -3 parentheses. You do have to use parentheses when you're multiplying or dividing fractions. It just works out better. 2 divided by 3. And close your parentheses like that. So -3 times 2/3, enter, and it's -2 or -2, which is what I have right here, -2. There's even a really fancy way to do this for those of you who already know it. -3 times, now, I am going to hit alpha y equals, and here you get to choose the fraction form that you want, and it gives you examples. So I'm going to choose that, just hit enter. See, look at that. Is that wild? I put a 2 up there and a 3 down there, and then I move out to the right, and then I hit enter, and I still get a -2 answer. But frankly, that's a lot of extra steps I didn't need to go to, and not every TI has those steps. Look how quick this was up here. I would stick with that, quite honestly. Okay, now I'm almost done, right? I have to add 1 to both sides. Sometimes I add vertically underneath, sometimes I just do it this way. -1 plus 1 is 0, so that leaves me with y equals 2/3 x -2 plus 1 is -1. And there's the answer. That's the equation of the line that goes through these 2 points, and that's all you know. You can find the equation of any line if all you know is 2 points for sure that are on the line. We're going to do the same thing again. because that takes practice.
Ma'am, this is recorded, correct?
Yes, it is.
Okay, I have to leave for an emergency, so I'll come back to the lecture later.
Sure, I understand. Good luck.
Thank you so much.
Our dean's wife died last night. He's the big boss of the math and science division, so kind of everybody in the math and science division is pretty upset right now. That was a bad thing too. Okay, find the equation of a line containing the given pair of points. You've got a line that goes through those 2 points. First, we have to find the slope. Then we find the equation of the line. So let's find the slope. I'm going to let this be x1, y1, and this be x2, y2. Okay, so m equals y2 minus y1 over x2 minus x1, and that is, okay, 7 minus negative 2 over 7 minus negative 2. Well, that's going to be 7 plus 2 over 7 plus 2, which is 9 over 9. Anytime you have exactly the same thing on the top and the bottom, the answer is 1. So this is 1. Our slope is 1. The very easiest slope in the whole universe to have. Now I'm going to find the equation of the line with the point slope formula. Y minus y1 equals m times x minus x1. Okay, so now, I don't like negative numbers, not any more than other people do, and that makes it really hard. So I am going to use my prerogative to choose this point this time, and I'll get exactly the same answer. You try it with the others and see if you don't get exactly the right answer. So I'm going to say y minus 7 equals 1 times x minus 7, which will give me y minus 7 equals x minus 7, because 1 times x minus 7 is x minus 7. Now I will add x to both, no I won't, I'll add 7 to both sides. This is interesting. Negative 7 plus 7 is 0, so I have a y left on the left. Negative 7 plus 7 is 0, so I'll have an x left on the right. And this is the line y equals x. Y equals x is a very famous line. Y equals x looks like this. It goes right through the middle of the axes, and it's at a 45-degree angle. 45 degrees here, and 45 degrees here. So it's more interesting than most lines. The line y equals x, whatever y equals x equals. So, because y equals x. Okay. Notice you don't have to have a y-intercept, when you don't have a y-intercept, there's an understood +0 there. So that your y-intercept is the point 0, 0, which is the center of the x and y axis, the very center. In math theory, the center is what creates the x and the y axis. They actually radiate out, sort of like a Big Bang theory. Okay, here's another one. Oh, and that's it. That's the last one. Oh, we can't get out this early. This is terrible. Okay, I thought it would take a lot longer than this. All right, here we are, and look, they're all negative. So, suddenly I'm here in blue, x1, y1, and x2, y2. And I'm going to find the slope. Why don't I find it up here just for a change of pace? y2 minus y1 over x2 minus x1. And they're all negative. So for that reason, I'm going to write it like this. So I will have -6 minus -3 over -4 minus -2, and that will give me -6 plus 3 over -4, -4 plus 2, and that'll be -3 over -2, which, as we know, negative over negative is positive. This is going to be +3 over 2. Okay, now I'll move to black. Come down here, y minus y1 equals m times x minus x1. So I might as well use x1, y1. They're all negative. So y minus -3 equals 3 over 2 times x minus -2 and the first thing I need to do, no skipping steps when it comes to changing signs. Negative over negative. I'm going to go back to blue for a minute. Negative times negative is positive, and negative times negative is positive. So you're going to have a sign change here. Y plus 3 equals 3 over 2 times x plus 2. Okay, so we'll have y plus 3 equals 3 over 2x plus 2 times 3 over 2. Now the quick way to do this is to recognize that this 2 and this 2 will cancel each other out, leaving you with a 3. But the slightly longer way to do this is 2 parentheses 3 divided by 2, enter, and then, oh, and then enter. I meant to close my parentheses and then enter. And the answer is 3. So y plus 3 equals 3 over 2x plus 3. And look what happens again. Minus 3 minus 3. We're going to have a line that goes through the origin, the very center of the x and the y axis. 3 minus 3 is 0. I'm left with just a y over here on the left, and 3 over 2x plus 0. So y equals 3 over 2x. And that is finding the equation of a line. Here we found the equation of the line that goes through the points -2, -3, and -4, -6, and an infinite number of other points. But those are the only two we know. And they're the only two we need to know to be able to find the equation of a line. We can know any 2 points and find the equation of a line. Any questions about this? You think you're going to be able to memorize, because you have to memorize the point slope formula and the slope formula, and the slope intercept formula and the standard form formula, because they're just parts of working with linear functions.
So we can always find the points if we have the point slope formula and the slope intercept form, right?
Yes. Most of the time, almost all of the time, you're going to be asked to find the equation in slope intercept form. But notice you don't have an intercept here, or you do, it's 0, 0. But yes, that's what equations of lines are for, is so you can find other points. In fact, all the equations you encounter are really just formulas. All the functions you encounter are just formulas for finding other points. Okay, I cannot in all good conscience go on and say, go ahead and get lost, or something more polite than that. Can't do it. So what we need to do is this. We need to do that. Yeah, and come up with a new document. I don't know, let's say 5 pages. And I don't even know what I'm going to call it, so we'll call it new document. And I'm going to make it a little bigger and put it over here. Ooh, watch this. Oh, didn't work. There. Now I am going to not use any of those for the moment, and instead I am going to pull up MyMathLab. No, teacher, don't. Yes, because I'm mean and cruel. Okay, here's what we talked about today, which was really only a few problems. Somehow I thought it would be harder than that. Okay, so now we are going to continue with what is hard. And this is perfect. From now on, I'll know I should always put them together. But we're really only going to talk about 2 problems. So that's not going to take very long, and you'll probably get out early anyway. we're still finding the equations of lines, but special lines. Okay, I just went on to the next section, which is finding the, and I'll change the dates, finding the equations of lines that are parallel and perpendicular to each other. And parallel is really easy, and perpendicular is kind of hard. Not that hard, but kind of hard. So we're going to do that. Notice that the first 4 problems are for parallel lines, and the second 4 are perpendicular. And let me tell you about parallel and perpendicular before we go on, so you can have a mental image in your brain. Let's take a blue line like that. And let's take a green line like this. These lines go side by side forever, and they never cross. They never cross. These are parallel lines, at least close to the Earth. Now, there is some talk, if you watch science shows on TV, about, well, parallel lines do touch. They do come together out in space because space is curved. Yes, out in space. But here on Earth, they stay side by side forever. Okay, so this is Euclidean geometry that you studied in high school. These are parallel lines. Perhaps not that well drawn, but they are parallel in my personal universe. You know, the great thing about parallel lines, they have the same exact slope. Their slopes are equal. Slopes of parallel lines and these are still being recorded, so the lady who left won't have to worry about it. Neither will anyone who's not here. Slopes of parallel lines are equal to each other. Not really true for perpendicular. Suppose you have a red line. Should make it go the other way. It's straight too. Pretend those curves aren't there. And how about a black line? If a black line is perpendicular to that red line, then it does cross the red line at a 90-degree angle. And this is the symbol for a 90-degree angle. A right angle, okay? Perpendicular lines cross each other at a right angle. Now that doesn't come into the equation at all, but that's sort of just so that you'll know. Some of you might be planning to go on to trigonometry, and you sure deal with perpendicular lines there. Okay, the X and the Y axis are perpendicular to each other. Okay, now, their slopes are obviously not equal. but their slopes do have a particular relationship. So that if the slope of the red line, if we were to call that M1, and if the slope of the black line were M2, then the particular relationship that those two have is that if you multiply M1 times M2, your answer is guaranteed to be -1. That's the peculiar relationship of the slopes of perpendicular lines. So parallel lines have the same exact slope. Perpendicular lines have slopes such that when you multiply them together, you get the answer -1. And now we're going to use those facts to find the equation of a line that is parallel to another line, and then the equation of a line that's perpendicular to a different line. And here we go. You have to learn how to read these questions. They are confusing at first, but once you understand it, it's not confusing anymore.
And Miss Rademacher, so every time that you multiply M1 times M2, is it always going to give us -1?
If the two lines are perpendicular, yes, guaranteed. But that's the only time. Only if the two lines are perpendicular. Okay, does that answer your question?
Yes, it does. Thank you.
Okay. All right, now, here's your first question. This one is about parallel lines. You've got a line. That goes through the point 2, -1. Along with an infinite number of other points. But this is the only one you know. So you've got this line that goes through that point. Now, also, that line we're talking about is parallel That should be an L. To this line, 16x minus 4y equals 5. How ugly. Okay. So you've got a line out here. And we could call that line L1 or just L. And this line goes through that point. And also it's parallel to this line. What is the equation of L1 up here? Now look what it says down here. So you have to learn to understand how they word it. Every math book in the universe, even on Mars. No, I don't know that. Find an equation of a line containing the point 2, -1 and parallel to the line 6x minus 4y equals 5. Maybe you don't find the way they word it kind of strange, but I did when I was a student. I had to learn to understand what they were saying. So this is what they're saying. Now, the first thing I need for L1, I need to find its slope. And I can't use 2 points to find its slope because I have absolutely no idea what another point on L1 is. But I do know it has the same slope as this line. So all I have to do is find the slope of this line. And I'll have it because L1, if it's parallel to this line, has exactly the same slope. So here we go. 16x minus 4y equals 5, and it's a plus 5. Now I'm going to subtract 16x from both sides. 16x minus 16x is 0, minus 4y equals negative 16x plus 5. Well, 0 minus 4y is negative 4y. Now to solve for y, I'll divide each number by negative 4. So here the negative 4's cancel, leaving me with y. Here I've got negative 16 divided by negative 4. That's going to be positive 4. Now here, watch carefully. I have positive 5 divided by negative 4. That's going to be minus 5/4. And this is the slope-intercept form of this line up here. They're exactly the same line, but now all I have to do is look at this line to know what the slope is. The slope of that line is 4, positive 4, which means that the slope of L1 is 4 because they're parallel lines. So now to find L1, or whatever it's named, I'm going to use y minus y1 equals m times x minus x1. And I'll use this for x1, y1. It's the only point I have. And m is going to come from having found the slope of that line. So I will have y minus negative 1 equals 4 times x minus 2. So I will have y plus 1 equals 4x minus 8. And then to solve for y, I'll subtract 1 and subtract 1. So I will have y equals 4x minus 9. Because I take away 8, I take away 1 more, that means I've taken away 9. And so that's the answer right here. The equation of L1, the line I'm looking for, is y equals 4x minus 9. And L1 goes through 2, negative 1, and it's parallel to y equals 4x minus 5/4. How do I know they're parallel? They both have slope 4. So here are the steps we use. As soon as you see parallel and parallel to any line, you're going to use the line to get the slope. And then if the lines are parallel, that's going to be the same slope you use for the other line that goes through the point. So you're going to use the point slope formula with the slope from the given line and the points that the other line, the new line, goes through in order to find the equation of that line. Now you can find any point. If you could live that long, you could find an infinite number of points that are on this line. It's true. Okay.
Miss Barbara, I have a question.
Yes.
So where it says negative 16x over negative 4 plus 5 over negative 4, why did it change to negative 5 over 4 instead of that positive 5?
No, go ahead. I shouldn't have interrupted. I'm sorry. What were you going to say?
No, you're okay. So I wanted to know why why the plus sign didn't go down, because if you notice, it says negative 16x over negative 4x plus 5 over negative 4. So I get that 16 divided by 4 is going to give us a positive 4x, but why is it negative 5 over 4 and not positive 5 over 4?
It is positive 5 over 4. It's positive 5 over negative 4, and 5 divided by negative 4 is a negative number, because positive divided by negative is negative.
Okay.
But it's a fraction. See, 4 doesn't go evenly into 5. This is actually, 5/4 is actually 1.25. So if you were using decimals, you would have gotten 4x minus 1.25. And that's what you would have gotten by taking positive 5 and dividing it by negative 4. You would have gotten a negative 1.25.
Yes.
But you're not allowed to use decimals in most of these problems. Not all of them, which is why you have to read the instructions carefully.
Gotcha. Thank you.
You're welcome. Now, we have taken care of the parallel. Let us move along. Oh, that's not how you do it here. To perpendicular. Yay, perpendicular. All right. These aren't really harder, but they look like they're going to be. All right, here we go. Find the equation of a line containing this point and perpendicular to this line. So this is the same form. Okay, you've got L2. And L2, here's a symbol, is perpendicular to 2x minus 4y equals 9. And this line, L2, is going to go through the point 6, 3. So if we were going to find the equation of L2, the first thing you might want to do is set up y minus y1 equals m times x minus x1. And you would say y minus 3 equals m times x minus 6. Now we're all set, but we don't know the slope, so we've got to find the slope. And we're going to use this to find the slope. I have to know the slope of this before I can figure out what the slope of a perpendicular line would be. So let's do that. Let us once again solve for y. Oh, oh, no, 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 no. No, 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 no. There. And I'm going to subtract 2x and subtract 2x. And 9 is positive, so there's a plus there. If it had been negative, there'd be a minus there. All right, now 2x minus 2x is 0. We'll bring down the minus 4y. We'll have 0 minus 4y equals negative 2x plus 9. And 0 minus 4y is negative 4y equals negative 2x plus 9. And then we'll divide by negative 4 and divide by negative 4 and divide by negative 4. Now, I have to find out, actually, nobody really cares about this. Sorry, guy. I need to find the slope. The slope is what counts, right? I mean, that's what I'm looking for. That's the whole reason I'm going through all this, is to find the slope. The slope of this line is going to be negative 2 over negative 4, which is positive 2 over positive 4. Looks like a 3. Which is 1/2. Okay, that's going to be the slope of this line. And I don't really care what that is. If you're interested, what it would have become would be y equals 1/2 x minus 9/4. Again, because positive over negative is negative. But now I know that the slope of this would be 1/2. And I would love to use the slope 1/2. But we don't have parallel lines, we have perpendicular lines. So what I need to do is I need to look at 1/2, 1/2, and then I need to find the opposite reciprocal. 2 words, opposite meaning opposite sign, and reciprocal meaning flipped. Since the slope of this line is 1/2, the slope of the perpendicular line, and that just means the perpendicular slope, the slope of this is going to be these two flipped, so 2 over 1. And then the opposite sign. This is positive, so this is going to be negative, and 2 divided by 1 is 2, so the slope of L2 up there is going to be negative 2. And to double check yourself, 1/2 times negative 2 is going to be negative 2 over positive 2, which is negative 1. Just what the slopes have to be for perpendicular lines. So now I know that negative 2 is going to be what I put in for M up here. So let's see. Y minus 3 equals negative 2 times x minus 6. And now I'm already defined the equation that is perpendicular to this line and goes through 6, 3. So real fast, I'll finish this up. Negative 2 times x is negative 2x. Negative 2 times negative 6 is positive 12. Y minus 3 equals it. I'll add 3 to both sides so that I can solve for y. Negative 3 plus 3 is 0. I'm left with a y equals negative 2x plus 12 plus 3 is plus 15. And this is the line that goes through that point, 6, 3, and is perpendicular to this line. So the only difference in how you do these two problems is that you have to recognize that the slopes of the parallel lines are going to be exactly the same, which is why finding the equation of a parallel line is so much easier. The slopes of perpendicular lines are going to be opposite signs and reciprocals. So that you flip and you make it the opposite sign if your lines are perpendicular. And now we have told the total story of how you find the equations of lines, all different sorts of lines. And you can go do it. I'm done. 3 minutes early, I think. Maybe 2 minutes late. 2 minutes late. Yeah. Okay, this was it. I'm going to stop recording in just a minute. Maybe I'll wait to save this. Maybe I won't wait to save it. Oh, it is Coreq. Okay, that's all. You guys are Coreq. Okay, equations of lines. And this is going in your lecture worksheets. And it will appear in your modules very quickly. And the video will appear relatively quickly. I'm surprised at how fast these videos are ready. If anybody else is here, have a good afternoon.
You too, Miss Rademacher.
You too.
Remember, I have office hours starting at 3. So feel free to come by and ask questions if you want to.
Are you on campus, Miss Rademacher?
No, I'm not. I am broadcasting from my living room.
I could have sworn you were in class. Look at the background.
I know, I chose that background.
Awesome. Okay.
But it makes me feel teacherly. I even put on a nice dress.
Aw.
Just so it could be like going to work. But I didn't have to drive to work. So that was nice.
That's nice. Alrighty, Miss Rademacher, I'm gonna head out. I'm gonna head to my next class. I might schedule a appointment, a one-on-one at 12:30 if that's available. If that's
Sure.
possible.
Just let me know a little in advance, okay?
Okay, I'll email you.
Okay, great. I'll be looking for it.
Awesome. You have a
Okay.
great day.
You too. Bye-bye. Bye-bye, everybody else. I better, oh dear. Where do I stop recording? Here. Okay, that's where.